Well, every now and again it happens, and the storm stops for a few seconds, and I can maybe make a video. Now, before going on with our, it's not really martial anymore, but it's no more marshalling. Before going on with that, I want to help us out in our endeavor. King, can you hear that thing behind me? You can guess what time it is. Well, you can see what time it is. Our endeavor in trying to make the system crash and trying to cause all sorts of multi-threaded trouble. I've pulled out of my bag of tricks a class that I've used for ages and ages called tick count. And you may have your own tick counting class. If you don't, this is one that you might want to copy down. Forget about that for a minute. Forget how this works. Okay, now certainly the starting tick count. When we create the object, and when we reset, start, suppose this is 0, start gets set again to tick count. So this is certainly the, I don't know why it's called start. Pause count. I'm going to get rid of that. Make it as simple as possible. No pause count. No pausing. Uh-oh, the hurricane's starting again. No zooming. Okay. Now it's really simple. No last ticks. Okay. So it only has one number, unless we don't even need this and anymore. Sorry to waste your time with this. It will be easier. Easier to see like that. Alright. So there are three main functions for this tick counter thing, and they are, two of them have a similar sounding name. Elapse with a capital E, which is a boolean value, and elapse with a little e, which returns a b-word value. One is a question and one is a number. Okay, so this one returns how much time has elapsed since the last call, right, since the last call to reset since the last since the last time we reset it, and then we reset. So we get the current tick count, we take whatever the starting ticks was and subtract that from the current ticks, and then set our new starting ticks to the current ticks and return the difference. This one is a boolean, which does not always reset. So this always resets. This sometimes resets. Now, what this does is it checks to see if this interval has elapsed since the last reset. So we get the current ticks, subtract from where we started. That's bigger than or equal to the interval. And this is essentially reset. Or say reset. Because we took this difference. Well, sorry, that's the current tick count. So resetting has the same meaning as setting the start tick count to the current tick count. So if this interval has elapsed, we'll reset and return true. Otherwise, we don't do anything, we just return false. So that's two functions. And the other is to just see how many ticks have elapsed since the last reset without doing anything. So this, in fact, is a const version of that. Because it returns how many ticks elapsed, right? But it doesn't reset. See this DW relax. That's the same. That making that difference is the same. So you could say, if you wanted, like that, and reset and return that, return this. But this is the same meaning. Reset, to just check again. Reset does take an argument, a secret hidden argument, which is you can translate. So you can reset it and say subtract some ticks so that you could start out you could make it appear as if the tick count had started out like so many ticks earlier. Okay. Now these are all positive values, so you can only translate backwards in time. You can't go forwards, and that makes sense. That doesn't make sense to say that a negative amount of time has elapsed. It has typical assignment, copy constructor, does the same thing, and that's it. It's a very, very simple class. Translate adds an amount to our start time. So you got to be careful with this one. I don't know why I introduced That one is a little dangerous, but I guess I want, because this only subtracts, I wanted to go forward. So, if I want to move my starting position ahead in time, I can use this translate. But this, we'll never use it. Let's get rid of that. Okay, so that's it. That's the entire class. Now, you'd think you couldn't do much with a simple little class like that. I'm going to prove you wrong. Now, I invented a macro to check for the escape key and quit the loop when I hit escape. I think that's useful for this. First, I'm going to declare one of our tick counts. I'll typically use a TK rather than TC because TC sounds like T car. I don't want to get confused. So let this tick counter represent our program time. Okay. So one thing I could do, if I don't do that, maybe what can I do that takes time? Sleep. Sleep for 1200 milliseconds. Program running time missing Okay, so you could declare one of these at the beginning of your program. And at the end of your program, you could print out how long your program was running for. Okay, and you don't have to do anything more about that. Okay, now let's suppose we go through our loop, and what I'm going to do here is say I want to keep this one as a total, so I'm going to have a second tick count, and I'll call this event. Or no, I'll let wake up. So I'm going to say that, let's suppose that, I don't know, I keep saying 1200, 1374 milliseconds have elapsed. And I'm going to print out the current program running time. And I'll keep doing that forever until someone presses the escape key. You notice it's not exactly right. there's some resolution problem. Get tick count is not a highly accurate counter. It also has a problem in that because it's a D word and it's limited size, so if you let it run for 49, 50 days about, then it wraps around. So your differences wrap around. Right. Right now it doesn't matter. You know, if a wraparound occurs with these differences, like suppose the current ticks, if the current ticks is FF, like that, right? And then I wait 5 milliseconds, then I'm going to get 4, right? The first one will wrap to 0, and then I get 4. That would be the result. I'll actually make it easier. Suppose I add 2, so this would be a 1. And to get the amount of time elapsed, I take my current time and I subtract the starting time. Right? Current time minus starting time. And if you do this difference, if you don't believe me, you can try it with debug. Well, we'll have to use words. I'm subtracting AX I want 1. Subtract from AX BX. Actually, doesn't matter, does it? Okay, and I get 2. So this difference will give me 2. Right? And since it's all unsigned numbers, there are never any negatives. Now what happens is if this difference is going to keep going up and up and up until eventually if the difference becomes FFFF, and then the next one becomes 0 again and wraps around. Same problem as always. Okay, so that's one thing you can do. Another thing you can do is you can invent a macro. What I have here. See these dummy bar things that I use all over the place? And the way that works, the way these things work, is that they combine like the file and the line number or whatever of the file with some name. Okay, so that way I can use the same dummy bar on 2 different lines and I won't get a conflict. And that allows me to make macros like this once every, okay? Now, so like I said, these dummy bars are unique, or they have a unique name, depending on where they're placed in a file. And that's the reason why, everything has a reason. That's the reason why all of these things are set to program database rather than edit and continue. You see, if you use edit and continue, then that means that you can edit the code as you're debugging it, which means that the line number for a particular line in a file can change as you're debugging. And so what that has the effect of doing is disabling the feature that allows me to make these unique variable names. And I'd rather have the names than the edit and continue. So that's why that setting is on. I'll show you that. That's like this. Get rid of this TC wake up, and I can do the same thing by saying once every this many milliseconds, do that thing. Now it's created a tick count variable called dummy var something. Okay. But I can still use that thing because now this is on a different line. So these are independent counters. It's not the same variable dummy var. Darn yet. See, one is counting very quickly, the other one's counting very slowly. So that means I can have things happening at sort of various rates. A friend of mine called this macro latch for some reason. And I think that's an analogy with these things called latch registers, which is something to do with microchips. Anyway, here's an example of something you can do with the once every. I made a little thing here. I don't know if you ever saw my video about the rotate thing. No, not that part. But at one point I wanted to make a batch file to do this. Well, to do part of this. Well, I suppose I could print this out as a string, but whatever. If I print these characters and a backspace first, then this is going to appear, this is a single slash, appear as like a little clock rotating around. So every 200 milliseconds, I print a back, this is a backspace, and then I print one of these characters according to this index. And all this macro does is it increments the counter and resets it if it happens to be equal to this value. So the number of elements in here is 5, right? So if I rotate is equal to 4, then I set it back to 0, right? Because there are 4. You have to do -1 when you do this kind of trickery. You see, I don't know if people teach you these things at school, but I never see people do it, right? Like, if for something like this, which is constant anyway, why call string length, right? You know how many elements are in the array, right? Because this type of setting, if you just get rid of this for a minute so it's cleaner to look at, when you set a string array in this fashion to this value, it sets the array elements, all right. And how many elements are there? 1, 2, 3, 4, and 5, the 0, right? So this is an array of 5 elements. So its string length is going to be 4. And not only is its string length 4, but it's not a number you need to store anywhere, right? It's a literal constant. This here is string length, but it's the preprocessor just sets this to the number 4. Anyway, so there's no computing going on here. That computation is done on that compile. Okay, now every 3 seconds, another one of my macros used. I print out the program's current time. So let's see this go. See the little thing spinning there? It spins around. I can add as many things as I want with this once every, Let's see, what else could I do? Change the direction of the spinner every 10 seconds. Let's say 0 is forward. How about int? One for forward and -1 for backward. Now, how do I make it go backwards or forwards? If it's going backwards, do I have a negative version of this, or do I just I can say either if it's that, I use that as positive, otherwise I'll go backwards, which means right? So if this is 0, if this the biggest this can be is 3, and this value is 5, that's 4, so I got to subtract another 1. Is that right? So at 0, I get 3, and then 1, all the way up to 3 is the maximum, right? 0, 1, 2, 3. So this is 3, 5, -5, 0. So that'll change the direction. Let's not make 10 seconds, we'll make 6 seconds. No, Let me get a weirdo number. Oh, spender. See, now it's going the other way around. So you can do lots of things with these tickers. And one thing I want to be able to do is to alter the way the timing in our thread stuff. Now the thread prompt itself, let's check the time here. So, okay, I just have enough time to show you what I've done with this. It's not really Marshall anymore. Maybe I can, whatever. There's no local list now. What I've done is, if it's a synchronous call, C-sync, then I do what I did before, saying, if it's an async call, I do the invoke, and then I add that call pointer object to a global list. And everything in that list will be something that has already been invoked and is ready to be deleted. Now in this file, I've invented a function called delete invoked calls. And what that does is iterate through the list, deleting all of the items in that list because they're done with, and then removing all the items from the list. Now, these deletions are going to happen in not in this thread. They're going to happen in this thread, in this loop, which will be a kind of loop. Oops. In fact, I'd like to do the same thing. I'd like to continue going around this loop, adding synchronous or asynchronous calls to the message queue of the other thread. And every now and again I want to do a cleanup. So that's why I got that tick counter ready. So I might say, every 2 seconds, take a run through and clean up the list. Now, as that's going on, as I'm deleting items from that list and deleting the list, the other thread is also accessing that list, and we're going to have multiple access to the same list. Okay. Not to the data is safe now, unfortunately. I'm trying to make things bad happen. We can work on making the badness happen too. But if we use that interface, then the data is safe. Because what I've done is auto call. I think I have it right. I wanted to get rid of that. Right. See, I'm not doing any malloc here. I'm doing the malloc at the same time here. This autocall, when you delete the autocall struct, it deletes its member, which has been malloc here. Okay. Here's the structure. Delete R0. That's the thing here. So that's where the data gets deleted, the string, and the objects in the list are accessed to that. One way of accessing the list is doing this. Another way is just accessing it anywhere. It's not protected in any way. Nothing's protected, and what I want to do is create a situation where we're going to get a crash, okay? And I'd like to be able to generate various kinds of crashes and then show how to stop that from happening, how to protect this global object from multiple thread access. Okay, so that's where we are. See you.